Everyone, in this video we will prove that every convergent sequence has a unique limit, and end of the video I will explain what is epsilon. So in here, if you want to prove that every convergent sequence, we need to assume that one convergent sequence. So let's assume that an is a convergent sequence. Okay, an is convergent sequence. Then we are trying to prove that it has a unique limit. So in this kind of sequences, or in many topics about mathematics, if you want to show that uniqueness, you can do that one. Let's assume that we don't have only unique limit, we have two limits. Assume that a and b are limits of the sequence an. So in here we will use the only definition of limit. If you say that a is the limit of an, the sequence an, what that means, for any epsilon greater than 0, you remember the definition, right? There exists n. Actually, I don't want to use capital N because I will use the same definition for the value of b. So let's say that this is not only capital N, n1, such that what do we have? For all n is greater than n1, we have what? Absolute value of an minus a is less than, and I have two definitions. That's why I will use epsilon over 2, and I will explain what is it. Let me explain it actually. We have epsilon greater than 0. This is our assumption, right? So when you assume that this kind of things, epsilon is not a number. Epsilon represents every number. So when you say that epsilon is greater than 0, this is not only one number. This is every number. So you can represent every number by epsilon, or sometimes if you want for mathematical beauty, you can represent it epsilon over 2, because you can create any number, any real number, by using epsilon or epsilon over 2. Doesn't matter for you, because if something is less than epsilon, it is already less than epsilon over 2, because you don't know what is it. You are talking about every number. Okay, this is what? This is the definition of limit an when n goes to infinity equals to a, right? Let's do the same definition for the value b, because we said that b is our limit as well. So also let's say that there exists n2, such that for every n which is greater than n2, now in here an minus b must be less than epsilon over 2. Again, epsilon can be any real number, so you can represent any number by epsilon or epsilon over 2, doesn't matter. So this is the definition of limits of an when n goes to infinity equals b, right? These are just definitions. Then how can we prove that we have unique limits? What did we do for now? We said that we have two limits. Eventually, if you prove that your two limits are equal, that means that you have one unique limit, right? In here you assume that two limits. So if you show that they are equal, that means your limit is unique. Now, how can we prove that a equals b? A equals b means that actually a minus b equals 0, right? It is enough to show that, prove that a minus b equals 0. Or sometimes it's enough to prove that absolute value of a minus b equals 0. You can use any of them. Let me use the third one, absolute value of a minus b, because in the definitions I have absolute value. So that is why I will use absolute value of a minus b is equal or not. Now, in here, we can say that, let's assume that n is the maximum of n1 and n2. So for every n which is greater than n, I will write this one because I will use these two definitions, both of them. So I want to prove that for both of them. Let's assume that n is the maximum value of n1 or n2. So when you say that for every n which is greater than n, that means for every n which is greater than n1, because n is greater than n1 or equal. And also we have for all n which is greater than n2 because n is greater or equal than n2 as well. So for every n which is greater than capital N, we have what? We are trying to find that absolute value of a minus b is 0 or not. Let's check. In here, can I add minus an and plus an? Minus an plus an is 0, right? So I can write it like this. A minus, this is actually still a minus b. And also, we can apply triangular inequality, right? Do you remember what is triangular inequality? You don't? Okay. Here, let's say that this is our first term and this is our second term. So we can separate that part a minus an plus the first term plus second term. So an minus bn. Why? Because in the definition, I already know that a absolute value of an minus a is epsilon over 2. So here you can see that this is less than epsilon over 2, right? Similarly, absolute value of an minus b is what? It is less than epsilon over 2 as well. So here is epsilon over 2, less than epsilon over 2. So we have epsilon. So eventually, absolute value of a minus b is less than, do not forget that this is not equality, this is less than epsilon. Absolute value of a minus b is less than epsilon. And also, you know the definition of absolute value, right? It must be always greater or equal than 0. So we know that this absolute value must be greater or equal than 0. And let's find the definition of epsilon. Actually, there is no definition of epsilon. It is any number which is greater than 0. This is the only definition of epsilon. You cannot pick epsilon. You are talking about every epsilon numbers. So epsilon can be 0.01. Epsilon can be 0.00001. Epsilon can be 0.000000 and goes to 0001. Epsilon can be very, very small number. So if your number is less than epsilon and epsilon can be any number which is greater than 0, the only option for a minus b, absolute value of a minus b is, it must be 0. If absolute value of a minus b is greater than 0, it cannot be less than epsilon because epsilon can be any positive real number. So in here we said that a minus b is 0. So if you know that, if you have that a minus b is 0, a equals b, right? So when you are, even if you assume that you have two limits, eventually you will get the same limit. So actually your limit is unique. That's it. This is our proof. And the definition of epsilon is this one. Epsilon is not only this one. It is also this one, and it is also this one, and it is also very, very small number, and also it is very, very big number. Okay, for more real analysis videos, you can subscribe my channel.